Hello! Alright, so the purpose of this video is to show you how that lovely quadratic formula works. Okay, so to use the quadratic formula, we need a quadratic equation in the form ax squared plus bx plus c equals 0. Okay, and basically if we were to get x by itself for this quadratic equation, the solutions to this equation are as shown. So as I went over in class, one way you can think about this is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a, where a is not equal to 0. Now the reason why a cannot be 0 is because if a is 0 here, when we divide by 0, we're going to have something that doesn't exist. So a just cannot be 0. And we'll see that for all the examples. A is always going to be something other than 0. Okay, so what I'm going to do to first start off is I'm going to revisit a problem that we went over recently. So remember we went over this problem in order to complete, so what we did was we solved for x by completing the square. Okay, I'm going to show you how you can solve this by using the lovely quadratic formula. Okay, so I'm going to go ahead and clear the screen here, and I'm going to go ahead and show that. Okay, using that exact same problem. So our example we have x squared minus 10x equals negative 13. And our goal is we want to use the quadratic formula this time. So if we're going to use the quadratic formula, what we're actually going to do this time is we're going to add 13 on both sides. So when we add 13 on both sides, this cancels, and we get x squared minus 10x plus 13 equals 0. Okay, like I mentioned in class, right? If you try to factor this, you actually cannot factor this. It's not factorable. But that doesn't mean that we cannot solve for x. We can still solve for x. Okay? And we're going to do that by using the quadratic formula. So the way we can use that, do this by using quadratic formula, basically what we have is, if you don't see a number here, you assume it's 1. Okay? So we have a is 1, b is negative 10, and c is 13. So let's go ahead and sing that quadratic formula song. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so all you gotta do is just plug in all the numbers here that you found. Okay, so x is equal to negative b, so negative times negative 10, plus or minus, so the square root, b is negative 10, so negative 10 squared, and then, I'm going to make this a little bit longer, minus 4 times a times c, and then we're dividing that by 2a, so 2 times 1. Okay, let's clean this up a little. 2 negatives become positive, so this is going to be 10, plus or minus, square root of negative 10 squared is going to be 100. So minus 4 times 1 is 4. 4 times 13 will get 52. Divide this all by 2. Okay, next what we're going to do is we're going to write this. We write 100 minus 52. So this is x equals 10 plus or minus 100 minus 52 is 48. So the square root of 48 divided by 2. Okay, do not forget this. I'm running out of room. Do not forget this. I'm just going to go ahead and clear the screen. Okay, continuing where we left off. So x equals 10 plus or minus the square root of 48 divided by 2. Okay, so what we're going to do is square root of 48 is going to be something like maybe 7.9 9 something. So it's not going to be a nice whole number or integer. So what we need to do is we need to break up 48. 48 can break up into 16 and 3. 16 breaks up into 4 and 4. Now, the thing about doing the jail cell and the partners in crime thing, if you actually find two partners in crime immediately, you can actually stop here. You don't have to break them into twos if you want. So if you wanted to, what we have is the square root of 48 is the same thing as the square root of 4 times 4 times 3. So what we can do here is, since we have two partners in crime that look identical, what we're going to do is we're going to get rid of one, because one gets shot, the other comes out of jail. So we have 4 times the square root of 3. So let's go ahead and write this here. So we have x equals 10 plus or minus the square root of 48 is the same thing as 4 times the square root of 3. And then we're going to divide by 2. Okay, next what we want to do is we want to divide this 2 into each term. So we have x equals, so we have 10 divided by 2 plus or minus 4 times the square root of 3 divided by 2. Next, what we can do is we can simplify this further. 10 divided by 2 is 5. Plus or minus, we have our constants on the out, so that we have this and this here. So we need to simplify 4 divided by 2. So 4 divided by 2 is just 2. So this is how you get 2 times the square root of 3. And as you see, this would be our final answer. So in other words, there's two possible solutions. We have x equals 5 plus 2 times the square root of 3, or we have x equals 5 minus 2 times the square root of 3. So this is one answer, and this is the other answer. And as you see, what we did here is exactly the same thing as what we got there. Isn't that crazy? All right, that is basically it. Next, I'm going to show you another example. Okay, bye. Hello. All right, so next what we're going to do is we're going to revisit another example that we did in class. So remember, what we did in class, we did this example. Okay, so what I'm going to show you now is how you would go ahead and solve this by using the lovely quadratic formula. Okay, so I'm going to write the exact same problem. So here we start off with an example. Let's say we have 3x squared minus 6x equals 6. Okay, so the way the quadratic formula works, we need ax squared plus bx plus c equals 0. So we want to zero out the right hand side. So we can zero out the right hand side basically by subtracting 6 on both sides. Okay, 6 cancel. We get 3x squared minus 6x minus 6 equals 0. So again, what I mentioned in class is if you actually try to go ahead and factor this, you're going to get something that's not factorable. But that doesn't mean that we can still solve for x. We can still solve for x. Okay? So the way we can apply the quadratic formula, we need to identify a, b, and c. A is 3. B is negative 6. C just so happens to be this one, so C is just so happens to be negative 6. All right, so let's go ahead and sing the quadratic formula a different way, the way that I made up maybe a couple weeks ago. All right, so x equals negative b plus or minus square root of b squared minus 4ac. Divide by 2a is what Mr. Chang sings. These are a few of my favorite things. All right, that is how that goes. All right, so let's go ahead and plug in these numbers. So x equals, so I'm going to plug in negative 6. It's negative times negative 6 plus or minus the square root of, so negative 6 squared minus 4 times a times c divided by 2a, so 3. X equals, negative times negative is going to be positive, plus or minus the square root of negative 6 squared is 36. 4 times 3 is 12. 12 times 6 is 72. So this is plus 72. Dividing it by 2 times 3, which is 6. Running out of room here. So I'm just going to go ahead and also write this here. So this is x equals 6 plus or minus. So square root of 36 plus 72. 36 plus 72 is 108. So 6 plus or minus 108 divided by 6. So you see this little part on the bottom here? Do not forget that, because I'm going to clear the screen now and rewrite it because I'm just running out of room. Okay, all right. So what I showed you earlier, we had x equals 6 plus or minus the square root of 108 divided by 6. Okay, what we want to do is we want to break up 108. Okay, because 108, if you take the square root of that, that's probably going to be like 10 point something, maybe 10.2, I don't know, something like that, maybe 10.3. But anyway, what we want to do is we want to break up 108. So 108, let's see, you can break it up into 36 and 3. 36 breaks up into 6 and 6. Okay, so actually what we have here is, again, what I showed you earlier, is whenever you hit pairs, you can actually stop. So what we have is, we have the square root of 108, and then equals the square root of 6 times 3. So what we have is we're looking for partners in crime. Here is our partners in crime. One gets shot, one comes out. This is 6 times the square root of 3. Okay, so what we have is this part. So x equals 6 plus or minus, and then we get 6 times the square root of 3, and then we're dividing by 6. Okay, what we can do now is we can divide by 6 for each of these terms. We have 6 divided by 6 plus or minus 6 square root 3 divided by 6. Now what we can do is we can reduce any fractions that we see. 6 divided by 6 is 1. 6 divided by 6 here is also 1. Basically, these cancel out. So all we're left with is the square root of 3. Okay, so what we have is x equals 1 plus the square root of 3, or we have x equals 1 minus the square root of 3. So these are two possible solutions that can come out of this. And would you look at that? This is exactly what we got here when we did that process called completing the square. So, isn't that cool? Isn't that awesome? Yeah, so a couple different ways that you could go ahead and solve this. All right, next I'm going to show you another problem. Okay, bye. All right, more problems. Okay, so let's try give you another example. Let's say give you something like this. So another example, 2x squared plus 6x minus 3 equals 0. So what we need to do is we need to identify a, b, and c. A is 2, b is 6, c is negative 3. Okay, let's go ahead and apply that quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what we have is we can go ahead and simplify this. So x equals, so negative 6 plus or minus square root of, we have 36, and then minus, so 4 times 2 is 8, 8 times 3 is 24, 2 negatives here, it's going to be positive, so 24, and then we're going to divide it by 2 times 2, which is 4. X equals, so negative 6 plus or minus 36 plus 24, square root of 60 divided by 4. Okay, what we can do is we can break up the 60. Okay, now 60 breaks up into, let's see, 15 and 4. 4 breaks up into 2 and 2. 15 breaks up into 5 and 3. So what we're going to get is we have the square root of 60 is the same thing as the square root of 5 times 3 times 2 times 2. Okay? So what we're going to get here is something interesting. So here are partners in crime. One gets shot, one comes out. So we get 2 times the square root of 5 times 3. Okay? Anytime that we cannot find any pairs for this guy, like, so all these numbers here are single numbers. So if they don't have any pairs, you have to multiply them together. So this is basically 2 times the square root of 15. I'm going to put that in a different color, actually. I'm going to put that in a different color. 2 times the square root of 15. Okay? So what we have is, let's go ahead and rewrite this. So we have x equals, so we have -6 plus or minus, and then I'm going to write that in yellows. This is 2 times the square root of 15, because that's the same thing as square root of 60. And what we're going to do is we're going to divide this by 4. Okay? Do not forget this. I'm just running out of room. I'm just going to rewrite it. Okay, so clearing the screen, we have x equals, so we have -6 plus or minus 2 times the square root of 15 divided by 4. Okay, what we want to do is we'll divide the 4 into each of the terms here. X equals to -6 divided by 4 plus or minus 2 times the square root of 15 divided by 4. Okay, so what I see here, this can reduce to 3 divided by 2. This can reduce to 1 divided by 2. So basically what we have, if you kind of see, so x equals to -3 divided by 2 plus or minus the square root of 15 divided by 2. So that's basically what we have. If you guys like to cancel out things, of course you can just write it. If you guys don't like the crossing out, you can just write it like that. But anyway, our two possible solutions from this, we have x equals -3 over 2, and then plus square root of 15 divided by 2, or we have x equals -3 divided by 2 minus the square root of 15 divided by 2. So these are our two possible solutions that come out of this. Okay, right. Now I'm going to go ahead and clear the screen, and I'm going to show you another example. So here we go with another example. Let's say I gave you something like 3x squared minus 18x plus 27 equals 0. Okay, same idea. What we need to do is we need to identify a, b, and c. A is 3, b is -18, c is 27. Okay, so now what we need to do is we need to apply that lovely quadratic formula. So like I mentioned earlier, so x equals -b plus or minus square root of b squared minus 4ac divided by 2a is what Mr. Chang sings. These are a few of my favorite things. Let's go ahead and plug this in. So we have -18 plus or minus the square root of -18 squared minus 4 times 3 times 27, and we're going to divide that by 2 times 3. X equals, this is going to be a positive 18 plus or minus square root of -18 times -18 is going to be 324, I think. Well, negative times negative is positive. Let's just do 18 times 18 just to make sure. And then we have 18, yeah, 324. Yes, okay, cool. Yes, it's going to be 324. Okay, so we have 4 times 3 is 12. 12 times 27. 4, carry the 1. 8, and then 24. So this is also 324. Wonderful. Okay, so what we have is this is going to be 324. We're going to divide it by 2 times 3, which is 6. Okay, 324 minus 324 is going to be 0. So we have x equals 18 plus or minus the square root of 0 divided by 6. Please do not forget this. We are just running out of room, so I'm going to go ahead and clear the screen. Okay. What we are left with, we had x equals. So we had 18 plus or minus the square root of 0 divided by 6. Okay. If you actually were to split this up, let's say we were to do it this way. So let's say without dividing the 6 into here, basically we have, or well, actually first let's take the square root of 0. Square root of 0 is 0. So we have x equals 18 plus or minus 0 divided by 6. So if we, let's say instead of dividing the 6, let's say we had x equals 18 plus 0 divided by 6, or we had x equals 18 minus 0 divided by 6. Is there a difference between any of these actually? If you add 0, as you can see, add 0, this is still 18 divided by 6. If you subtract 0, we're still going to have 18 divided by 6. So actually, these two are the same, and we only have to write 1. So we just have x equals 18 divided by 6. So basically, this implies that x is going to equal 3. So in this particular example, this would be something where we'd only have one solution. Compared to like the other examples that I've showed you, we'd had two possible solutions. This just so happens if, let's say you add and subtract something and you just so happen to get a square root of 0. This would be a case where you're going to have one solution. All right? Okay, so that's basically it for this video. I'm going to show you a few more examples. All right, bye. More examples. All right, let's do more examples. So another example. So let's say we have negative x squared plus 5x plus 2 equals 0. Okay, so this is all matter of preference. If you prefer, if you want to do a equals negative 1, b is 5, c is 2, that is fine. What I like to do, actually, so I like to get this x squared term as positive. So one way we can get it positive is basically we can add everything to the, or add or subtract anything that we see on the left hand side and put it on the right hand side. So if I did something like this, basically what's going to happen, all these things are going to cancel. We're going to get 0 equals x squared minus 5x minus 2. Now we can say, well, a is 1, b is negative 5, and c is going to be negative 2. So something like this. All right, so now let's go ahead and apply that lovely quadratic formula. All right, so we have x equals, so negative b, so negative b, so b is negative 5, plus or minus the square root of, so b squared minus 4 times a times c divided by 2 and then a. So what we have here, we have x equals, so we have negative times negative is going to be positive 5 plus or minus the square root of, we're going to get negative 5 times, negative 5 squared is going to be 25. So minus 4ac, so this is going to be a plus 8, okay? And then we're going to divide it by 2. Okay, actually I'm just going to get rid of that there. The square root didn't go as long as I wanted to. 25 plus 8, so x equals 5 plus or minus the square root of 33 divided by 2. All right, so if you try to break up 33, as you see, so 33 will basically break up into 11 and 3. So what we have is the square root of 33 is the same thing as the square root of 11 times 3. But the issue here is there's no more pairs. There's not a partner in crime that gets shot in this case. So anytime that you don't have partners you can pull out, basically just multiply these numbers back. So 11 times 3 is square root of 33. So basically what this means is this was already in simplest radical form. We cannot break that up any further. So as you can see here, so sometimes you run into situations like that where you cannot, where this is actually already in simplest radical form. So what this means is, so I'm just going to write our answer here. So we have x equals, what we can do is I can actually divide this through. So this is 5 over 2 plus or minus the square root of 33 divided by 2, as you can see there. So what this implies is that our two possible solutions are x equals 5 divided by 2 plus square root of 33 divided by 2, or we have x equals 5 over 2 minus the square root of 33 divided by 2. So these right here are our two possible solutions that can come out of this. Okay, so as you see here, I want to show you something interesting as well. So as you look at this, this is what we used the quadratic formula on. So let's say you actually were to actually complete the square with this. If you try to complete the square, you would have b equals -5, and then -5 divided by 2 is going to be an ugly fraction. So whenever you have situations like this, it might not be the best idea to go ahead and try to do complete the square. It can be quite messy if you have to deal with those fractions. Okay. Anyway, I'm going to clear the screen. Show you another example. Let's say we have something like this. X squared plus 9x plus 8 equals 0. Okay, so again, what we want to do is we need to identify a, b, and c. This is a 1 here, so a is 1. And then we have b is 9, c is 8. We need to apply the quadratic formula. So x equals, so negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -9 plus or minus square root of, so 9 squared is 81. 4 times 1 times 8 is going to be 32 divided by 2. X equals -9 plus or minus square root of 81 minus 32 is going to be 49. Divide that by 2. Square root of 49. I see that's a nice square root. So square root of 49 is 7 divided by 2. So remember this. Do not forget this. I'm just running out of room. Okay, so I'm going to go ahead and clear the screen. So we have x equals, so negative 9 plus or minus 7 divided by 2. Okay, so what we can do with this is, so actually we can try to avoid dividing first. Let's try to do something. Let's say just split this up. So x equals -9 minus 7 divided by 2, or we get x equals -9 plus 7 divided by 2. Okay, let's go ahead and clean this up. We have 9 minus 7, so that's going to be -16, so divided by 2. Or, in this case, we get x equals -9 plus 7 is going to be -2 divided by 2. So, our two possible solutions are x equals -8 or x is equal to -1. So, these are our two possible solutions that come out of this problem. Alright? Okay, that's basically it for these. Okay, I'm going to show you one more set of problems very soon. Okay, bye. Alright, last couple problems. Here we go. Okay, so what you can do with this one, so let's say I give you -3x squared plus x plus 2 equals 0. So imagine there's a 1 here. Okay, so it's 1x. So one way you could do it, you could say a is -3, b is 1, c is 2. You could do it that way if you want. Again, what I mentioned in the other video is what I prefer. You don't have to do it that way, but what I prefer is I like just getting this x squared term. I want this term to be positive. So in order to make it positive, what I can do is I can get all the terms from the left hand side and move it onto the right hand side. So we're going to add 3x squared, we're going to subtract x, we're going to subtract 2. And we're going to do that exactly as you see right there. So what we have is this cancels, we get 0 equals, we get 3x squared minus x minus 2. Okay, so once we have brought all those terms on the right hand side, we have a equals 3, b is equal to, so this is going to be a -1, right? So this is going to be -1, c is going to equal -2. Maybe I'll leave that there. I'll leave that there just so you guys can kind of see it. Okay, so next what we're going to do, apply the quadratic formula. x is equal to, so negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals, so negative times negative is positive, plus or minus the square root of, this is 1, and then two negatives become positive. 4 times 3 is 12, 12 times 2 is 24. Okay, divided by 2 times 3, which is 6. 1 plus 24 here. So x equals 1 plus or minus the square root of 25 divided by 6. Running out of room. Running out of room, do not forget this. I'm going to go ahead and clear the screen. Clearing the screen. X equals, so we have 1 plus or minus the square root of 25 divided by 6. Okay, so what we have is we can go ahead and simplify it. Square root of 25 is 5. X equals 1 plus or minus 5 divided by 6. Okay, what we can do again, if you wanted to, you could put 1 over 6 plus or minus 5 over 6, and then you could also add or subtract those fractions if you want. If you don't feel like doing that way, you can also do it like this. You could say x equals 1 plus 5 divided by 6, or we have x equals 1 minus 5 divided by 6. Do this separately. We have 1 plus 5 is 6. And then we have 1 minus 5 is going to be negative 4 divided by 6. What I see here, 6 divided by 6 is 1. This is one of the solutions. Or we get x equals to negative 4 divided by 6. That's going to be 2/3, as you can see there. So what we get is this is x equals negative 2/3. And that's exactly what we got. That's what we get for the result. Okay. All right. Let's show you another example. All right. Last example. Here we go. So we have 2x squared minus x minus 5 equals 0. Okay. We have a negative in front here. It's a negative 1. So basically we have a is 2, b is negative 1, c is negative 5. Let's go ahead and apply that quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac divide by 2a is what Mr. Chang sings. These are a few of my favorite things. Negative times negative is positive. 4 times 2 is 8. 8 times 5 is 40. Divide by 2 times 2, which is 4. X equals 1 plus or minus 1 plus 40 is going to be 41 divided by 4. 41. If you try to break up 41 just breaks up into 1 and 41. So unfortunately, or I won't get anywhere, but that's good because that means this is a right in simplest radical form. Okay. So what we can do is we can actually break this up. We can divide the 4 through, so we have x equals, so we have 1 over 4 plus or minus the square root of 41 divided by 4. Okay, so what this means is basically we're going to have two possible solutions that come out of this. So what we have, I'm just going to write this over here. So we have x equals 1/4 plus square root of 41 divided by 4. That's one of the solutions. Or we have x equals 1/4 minus the square root of 41 divided by 4. So this would be the other solution. All right. And that is basically it. Okay, I want to show you something else interesting. This is going to be the last part of this video. Okay, so I'm going to clear the screen. I know for some of you, maybe the simplest radical form thing is kind of new to you. So let's go ahead and do some examples. Okay, square root of 27, right? 27 breaks up into 9 and 3. 9 breaks up into 3 and 3. So square root of 27 is basically the same thing as square root of 3 times 3 times 3. So actually, we have three identical numbers. So what this actually means is that these, you just circle 2 of them. So you have 2 partners in crime. Still, one gets shot, one comes out. So it's actually 3 times the square root of 3. Okay. So that would be a different case to what I showed you earlier, right? So plus or minus. So don't forget that. Okay. Square root of 10. 10 breaks up into 2 and 5. So this is the square root of 2 times 5. There are no pairs or we don't have pairs. There's no number that we can pull out. So this is basically just 2 times 5. So basically, square root of 10 is, so plus or minus square root of 10. This is basically its simplest radical form. It doesn't go any further. Okay? Next, square root of 125. Okay, so 125 breaks up into 25 and 5. 25 breaks up into 5 and 5. So same idea here. Square root of 5 times 5 times 5. You just circle one pair. So 1 gets shot, 1 comes out. 5 times the square root of 5. Okay, so that is what we get. Okay, let's say I gave you something like the square root of 30. If I had you break up 30, right? 30 basically breaks up into 2 and 15. 15 breaks up into 3 and 5. So what we have is the square root of 30 is basically the same thing as square root of 2 times 3 times 5. So in this case, actually, again, we don't have any pairs that we can, we don't have any pairs, so no numbers come out. Since no numbers come out, just multiply them back together. 2 times 3 is 6. 6 times 5 is 30. Unfortunately, this means that this, as you can see here, is just in simplest radical form. Okay, I'm going to clear the screen. Let's say I gave you something like the square root of 37. 37 breaks up into 1 and 37. So guess what? We can't go any further. Square root of 1 times 37, right? So basically there's no pairs that we can pull out. So this is just the square root of 37. That's in simplest radical form. Last problem, square root of 39. 39 breaks up into 13 and 3. 13 and 3 are prime numbers. Square root of 13 times 3 here. Again, no more partners in crime. No more partners in crime. You have to multiply them together. So square root of 39 is basically already in simplest radical form. So like this is fine and this is fine. All right. Woo! That was a lot. All right. So let me know if you have any questions on anything I went over. Okay. Bye.